So today we're going to talk about indirect proofs. Let's begin by writing on step number 1. Okay, indirect proofs are written just a little bit differently than we've been doing so far. So instead of having, let's say, a 2-column proof, we'll be working with a paragraph proof. So it's written in 3 separate steps. So our first step is to actually assume that our conclusion is false. So if we're given L is parallel, not parallel to M, so this is line L, and it's not parallel to line M, then we're going to say that our conclusion is angle 1 cannot be congruent to angle 3. So we're going to begin by assume that angle 1 is congruent with angle 3. So just like we did yesterday, if it's telling me that if this, then that, then the first thing we're going to start with is whatever we would start with is our contrapositive. If this is P and this is Q, and we're working with if P, then Q, the way to do the contrapositive would be if not Q, then not P. Let's just put like that as a side note over here, not part of our proof. Kind of just reminding us where we're trying to go. Okay, so assume that angle 1 is congruent with angle 3. So let's write our step number 2. And step number 2 is to show the assumption leads to a contradiction of the hypothesis. So we're going to take this assumption and we're going to lead in paragraph form to the conclusion being false. Okay, so let's see what that looks like. So first, I'm going to point out that if angle 1 is congruent with angle 3, then angle 1 and angle 3 are, look at angle 1 and angle 3, they are corresponding angles. Okay, what do we know about corresponding angles and the angles being congruent? Well, this takes us straight to our conclusion. Let's see, how would we write it? The period here. If 2 lines are cut by a transversal being this line here, and 2 angles are, let's back up a little bit, not 2 angles. How about, and specifically, corresponding angles, that would make more sense. And corresponding, wait, I don't have to repeat myself. Corresponding angles are, I'll abbreviate here, got enough writing that we're doing, are congruent when the lines are, I'm going to go ahead and write this one out, parallel. So that right there basically takes us, this completely takes care of step number 2. We have shown the assumption leads to a contradiction of the hypothesis. If this is our hypothesis, we just contradicted our hypothesis by saying that the lines are parallel. So step number 3, let's switch back to my color here. Step 3, oops, fix that really quick. So step number 3 is to actually point out that because the false conclusion leads to an incorrect statement, the original conclusion must be true. So I'm going to say that L being parallel to M contradicts the given fact that L is not parallel to M. Thus, angle 1 is not congruent to angle 3. So basically, we assume that this isn't true. We go through the steps that we normally would with our clues when we're given our given statement and going back from our clues. We're working backwards to do so. Let's try another one to see if it's a little bit easier. Okay, so let's start here. There's step 1. And let's look at our given here. Alright, so I have MO, which is right here, MO is congruent to ON. MP, which is right here, is not congruent to NP. So we want to prove that MOP, angle MOP, is not congruent to angle NOP. So before I can't even really wrap my head around where I'm going to start with this, or how I'm going to get from here to here. But I know my first step is to assume that this conclusion right here is false. So I'm going to say that angle MOP is congruent to angle NOP. So let's look at that really quick. MOP is congruent to NOP. So that would tell me that this is congruent to this. And I'm given that M is congruent with, or MO here is congruent with ON. We now need to go on to say step number 2. Alright, step number 2. And we can start writing this, instead of talking about it, start writing out our thinking as we go through this. Okay, so as I was saying, MO and ON are congruent. So I'm going to say, let's see, angle MOP is congruent with angle NOP. And MO is congruent with ON. And OP is congruent with OP by reflexive property. I just showed that this is also congruent. So how would we say this? If I can see it clearly now, I have a side, angle, side, side, angle, side. So I said this angle is congruent, and this side is congruent, and this side is congruent by reflexive property. And I say, so, MOP, triangle, MOP is congruent with triangle. So going with MOP, we'd have to say MOP. And then write triangle MOP. Side, side, angle, side. Now I've got all of this. Now I can say that this triangle is congruent with this triangle, which is this triangle and this triangle. Now I can say MP is congruent with NP because corresponding parts of congruent triangles are congruent. And there I have it right there. I just contradicted the hypothesis. Right? Let's put it right here. That's all that. We just found it. So let's go on to our step number 3. Let's look here. How would I exactly word step number 3? Okay, so being that MP is congruent to NP contradicts the hypothesis that MP is not congruent to NP. Thus, because we proved with the statement here that NP would have to be congruent with NP, since that contradicts our hypothesis, then we can say, in fact, that angle MOP could not possibly be congruent to angle NOP, because you would need MOP and NOP to be congruent in order to say that side, angle, side. I also think it's important to say that the wording doesn't have to be exactly perfect in here. Even more so than what we were doing with the paragraph proofs. As long as you can flow with it, if you can say angle, and then a side, and then a side, and then have all of that flow, and back up what you're saying to reach to that contradiction. That's the key right there. Reaching this contradiction. Once you reach the contradiction, you can now say that it is, in fact, true. Okay, that's about it. Pretty easy lesson today.